Step 1. Place the instrument on a sturdy and level testing bench. Step 2. Connect the power supply at the rear of the instrument. Connect the temperature probe. Step 3. Remove the instrument's transport protective cover and store it properly. Install the rotor protection sleeve locking ring, do not tighten yet. After installing the protection sleeve, tighten the locking ring. Mount the temperature probe fixation block onto the protection sleeve. Step 4. Turn on the power, the screen will light up automatically. Note, all rotors must be removed during the level adjustment process. The instrument will enter the level adjustment interface automatically. Observe whether the leveling indicator dot is centered. If not centered, adjust the leveling foot nuts until the dot is perfectly centered. Tap the icon in the lower right corner to perform zero calibration. After calibration is complete, enter the measurement interface. Align the selected rotor with the slot at the rotor connection point. The rotor is secured by magnetic attraction. Pour the sample into a 500 ml container with a diameter greater than or equal to 85 mm. Position the container center below the rotor, then rotate the lifting handwheel to slowly immerse the rotor into the sample. Avoid bubbles adhering to the rotor during immersion, and align the sample liquid level with the rotor's marked scale line. Install the temperature probe into the fixation block and immerse it into the sample. Start measurement. Step 1. In time-stop mode. Temperature displays real-time temperature from the temperature probe or thermostat. Runtime shows the currently set operating duration. Recommended to set initial runtime to 10 seconds for rapid measurement. Shear rate. Instrument calculates and displays shear rate based on selected rotor and speed. Speed, set to rotations per minute, RPM, completed by the rotor. Recommended initial speed is 10 revolutions per minute for low-speed measurement. Rotor, tap to select rotor type. BGD 168 has 3 models covering different measurement ranges. Multiple rotors are available to handle various measurement ranges. Tap to switch rotor types. The full scale of the selected rotor is displayed above. After selecting the rotor, tap the return key in the lower left to save. Step 2. Tap Run to start measurement. Instrument begins measuring sample viscosity and displays current torque. Since the current torque is below 10%, the instrument will issue an alarm reminder. Tap Speed and increase to 20 revolutions per minute. Tap Run. A torque reading between 10% and 100% indicates valid viscosity measurement. A torque around 50% is recommended for optimal accuracy closest to the true viscosity. Set run time to 120 seconds for more stable viscosity measurement. Screen displays real-time viscosity/time data curve. Instrument stops automatically after run time ends. Tap Save to enter data save interface. Here you can view the file name and measurement parameter information for this record. Insert USB drive into the rear port. Tap Save button to export data. Enable autosave function. Instrument automatically saves data to USB during operation. Speed ramp mode. Tap icon in lower right corner. Select speed ramp mode. Tap rotor to select rotor type. Using rotor number 2 as example. Set the initial speed to 10 revolutions per minute. Set the speed increment to 1 revolution per minute. Set the number of increment steps to 40. Set the operation time to 10 seconds. Click Start Test. Click Run. The program will gradually increase the speed from 10 revolutions per minute to 50 revolutions per minute. To measure sample viscosity performance at different speeds. After measurement, tap Save to enter data save interface. Tap Save button to export data. Instrument operation complete. Cleaning procedure. Rotate the lifting handwheel to raise the rotor and protective sleeve. Continue until the protective sleeve is higher than the container opening. Pull the rotor outward from the slot to remove it. Wipe the rotor surface with a paper towel. Remove the temperature probe. Wipe the probe surface with a paper towel. Wipe the protective sleeve surface with a paper towel. Loosen the locking ring and remove the protective sleeve. Apply appropriate solvent to a lint-free wipe based on the sample properties. Thoroughly clean the rotor, protective sleeve, and temperature probe. Instrument coefficient calibration. Let instrument stabilize for 12 hours in standard laboratory temperature/humidity before calibration. Prepare standard viscosity oil for calibration. Pour calibration viscosity oil into container. Place container in water bath for over 3 hours at constant 20 degrees Celsius. Remove calibrated viscosity oil after temperature stabilization. Position container center under rotor. Rotate lifting handwheel to slowly immerse rotor. Avoid bubbles on rotor surface during immersion. Align liquid level with rotor mark. Install temperature probe on fixation block and immerse into sample. In instrument measurement interface, tap rotor and select rotor requiring calibration. Set run time to 120 seconds. Tap speed, select a speed. Full scale must not be less than CP value of standard oil viscosity. Recommended full scale is about 110% of standard oil viscosity. Tap run to perform viscosity measurement. Check if instrument requires calibration. BGD 168 accuracy is plus or minus 1% of full scale, which is 1% of the current full scale viscosity range. Standard oil viscosity may have 1% deviation. Total allowable error equals 21.69. As measured, silicone oil viscosity is 508.65, exceeding allowable error. Instrument requires calibration. In instrument measurement interface, tap icon in lower right corner. Tap settings to enter setup interface. Tap calibration. Enter password 250,000 to access calibration interface. Tap coefficient calibration to enter coefficient calibration interface. Enter calibration viscosity of silicone oil. Tap confirm to start calibration. After calibration is complete, measure the sample viscosity once more. Recalibrate if exceeding viscosity tolerance after recalibration. Current measured viscosity 970.21 is within allowable error range. Rotor calibration completed.